Hey everyone, and welcome back to another Prep to Perfection Grade 12 Maths class. Just a quick reminder, if you boost your marks, you stand a chance to win 5,000 Rand. How amazing. Simply click the link down below to enter the competition. I'll now hand you over to your tutor, Camilla.
In today's video, we're going to look at sequences. A sequence is a list of numbers or objects in a specific order separated by a comma or semicolon. The sequence 2, 4, 6, 8. 2 is the first term or T1, 4 is T2, 6 is T3, 8 is T4. The three dots means it goes on till infinity. We'll be looking at two types of sequences, arithmetic and geometric sequences. What is an arithmetic sequence? It is a sequence of numbers where the difference between consecutive terms is constant. The general form: if A is the first term and D is the common difference, which can be positive, negative, or zero, A is the first term, term 2 is A plus the difference, term 3 is A plus 2 times the difference, and term 4 is A plus 3 times the difference. An example, given the sequence 2, 5, 8, and 11, A, our first term, is 2. The common difference is worked out by saying T2 minus T1, which is 5 minus 2, which gives us 3 as our common difference. We can double check this by using the other terms. Since our difference is constant, we should get 3 for all of them. The general formula for an arithmetic sequence is the nth term formula. We say the nth term is equal to A plus open brackets n minus 1 close brackets d. To determine if it's an arithmetic sequence, we have to make sure the difference is constant. The sum of the nth term of an arithmetic sequence is determined by using the sum formula. L in the last formula is the last term needed, which can either be given or we can determine by adding the difference. Find the sum of the 5 first terms for the sequence 2, 4, 6, 8. 8 is term 4, but we don't know what term 5 is. We're going to start off with the first formula. We need N, A, and D. We know that N is the fifth term, A is 2, and the difference is term 2 minus term 1, which will be 2. We can then plug these values in to our formula given. We plug all this into our calculator and we get that the sum of the nth term is 30. If we had to use the formula at the bottom, we need N, A, and L. We know A and N. L is our last term, term 5, so it's 8 plus our difference, which gives us 10. We just plug these values into our sum, and the sum of the nth term is 30. Given the sequence negative 40, negative 10, negative 6, and 174, determine the number of terms in the sequence. We know that the first term is 14, the difference is 4, Tn is 174, and n we are not sure at this point. The first step is to determine if it's an arithmetic sequence. We do this by making sure the difference is constant. We take the difference of any two terms and see if they are equal. Negative 10 minus negative 14 should be equal to negative 6 minus negative 10. And this is 4 is equal to 4, so we know our difference is constant. The next step is to find the formula of the general term. We know that the general formula is Tn is equal to A plus open brackets n minus 1 close brackets d. We just sub our values in that we know. We simplify the formula. Our last step is to determine the number of terms in the sequence. We know that the nth term is 174, so we plug that in. And now we have to determine what is n. So we plus 18, then we divide each side by 4, and this gives us 48 is equal to n. Therefore, we can say that the number of terms in the sequence is 48. What is a quadratic sequence? It is a sequence of numbers where the second difference between consecutive terms are constant. The general form: if A is the first term and R is a common ratio, T1 is A, T2 is A times R, T3 is a times r to the power of 2, T4 is a times r to the power of 3. An example, given the quadratic sequence below 2, 6, 18, and 52, we can say that a is 2, and r, our common ratio, we work out by saying term 2 divided by term 1, and this is 6 divided by 2, which gives us 3. We can test this out by using the other terms. Term 3 divided by term 2, 18 divided by 6, this gives us 3 as well. The general formula. To determine the nth term for a quadratic sequence, we say Tn is equal to a times r to the power of n minus 1. To determine it's a geometric sequence, we need to show that there's a common ratio. An example, find the fifth term of the sequence 3, 6, 12, and 24. We'll be using the general formula for a quadratic sequence. We need to determine r, which is 6 divided by 3, which equals 2. A is our first term, which is 3, and n is 5. We plug these values into our formula, giving us an answer of 48. The sum of the nth term of a geometric sequence is given by the sum formula. It must be noted that r cannot equal positive 1 because positive 1 minus negative minus 1 will give us 0 at the bottom of a fraction, and this is undefined. Find the sum of the first 4 terms of the sequence 5, 15, 45, and 135. We'll be using the sum formula. A is 5, n is 4, r is 15 divided by 5, which equals 3. We plug these values into our sum formula. Therefore, the sum of the fourth term is equal to 200. Find the sum of 2, 1, 0.5, and 0.25. A is 2, r is 1 divided by 2, which gives us 0.5. We plug these values into the sum to infinity formula. The answer is 4. The third term of a geometric sequence is 16, and the fifth term is 64. Find a and r. We're going to use the general formula for a geometric sequence, and we're going to plug the given values for each term. Then we're going to divide the two terms by each other. So we're going to divide the fifth term by the third term. 64 divided by 16 will give us 4. Then the two 8's cancel out. R to the power of 4 divided by R to the power of 2 gives us R to the power of 2. We square root either side, which should give us plus minus 2 as the answer. However, r is greater than 0. We then can sub r equals 2 into our general formula, which gives us negative 16 is Tn is equal to a times 2 to the power of 3 minus 1.
Alright everyone, that's it for today. But don't forget to keep practicing so that you stand a chance to win 5,000 Rand. Click the link down below to enter the competition, and we'll see you in the next class.